So let's move on now to start talking about the reactions of amines. And I'll start with a reaction that's pretty bad or does not give the desired product. So amines are good nucleophiles, and we know that good nucleophiles readily undergo SN2 reactions as long as we're treating them with alkyl halides that are sp3 hybridized and unhindered. And a great alkyl halide for SN2 is benzyl bromide. So if you take ethylamine, a primary amine, it'll attack and displace benzyl bromide through SN2. And that'll give you this secondary ammonium ion intermediate. But there is more than one molecule of ethylamine in solution, and therefore you'll have some molecules that have gone on to react, while at some point other molecules are waiting in line to go. And so what could happen is one of the primary amines might encounter the ammonium ion and do acid base just to deprotonate there. And if that happens, then it's going to give us a new lone pair on this, what is now secondary amine. Okay, so if the primary amine deprotonates the secondary ammonium ion, then you're going to get this product, this benzyl ethylamine. And the secondary amine we have here is more electron rich. Therefore, it's more basic and more nucleophilic than the primary amine, all right, because it has two sigma donors now, or two alkyl groups, which means the secondary amine will continue to react with the SN2 electrophile benzyl bromide. And eventually, that's going to lead to a quaternary ammonium salt or a quaternary ammonium product. So, for example, it would react again, same mechanism as before, where we get now two benzyl groups attached to the central nitrogen. That could deprotonate to become neutral. And then it will react again, because it still has that lone pair, with a third equivalent of benzyl bromide, and it will lead you to this quaternary ammonium salt. So SN2 reactions for amine synthesis are pretty bad. You don't want to use amine nucleophiles to make more heavily substituted primary, secondary, or tertiary amines, because these reactions will do overalkylation. So please try to avoid these in synthesis. If you're trying to stop at the primary, secondary, or tertiary amine and not go all the way to this tetraalkylated product, then you have to use a different method. And so I'm going to show you here two other SN2 methods that we have done before. And we've done these in Orgo 1. You've seen some of them again in Orgo 2 already. So if you have a primary alkyl bromide that's sp3 and unhindered, like this propyl bromide substrate, and you add a weak base like cyanide, where carbon is still very nucleophilic, then this will do an SN2 reaction, especially in an aprotic solvent, where cyanide simply replaces bromide in a concerted step. And if you want to make an amine, now we've done that by making a new carbon-carbon bond. Okay, so we've gone from 3 carbons to 4. The goal generally after that is to make the primary amine. And you can do that by catalytic hydrogenation or reduction, because that CN triple bond will just reduce down to a CN single bond, or we've added hydrogen gas across triple bond twice. So there are new H's on this carbon, 2 of them, and 2 hydrogens on the nitrogen. So if you want to go from an alkyl halide to a primary amine via a 1 carbon elongation, cyanide's a great trick for that. We've seen cyanide do a bunch of interesting things in this class, and one of those is SN2. Now, if you want to go from the 3 carbon alkyl bromide to a 3 carbon primary amine with no chain elongation, then you use this nucleophile here, azide. And the azide will attack and kick out bromide in a concerted step, installing a new carbon-nitrogen bond. And azide has a negative charge on one nitrogen with positive on the other. It's a zwitterion. And if you hydrogenate this, the first nitrogen here turns into NH2. The other nitrogens are lost irreversibly as nitrogen gas, or we break this weak nitrogen-nitrogen bond. And that gas evolves from the solution and makes the reaction irreversible. Remember that nitrogen gas is the most stable compound really that's known. It's 80% of the atmosphere, and it's the best leaving group in the world. So use azide if you want to make the primary amine from the bromide with no chain elongation, or we're staying at 3 carbons relative to the starting material. So those are 2 simple methods of SN2 that don't use amine nucleophiles. They use cyanide or azide nucleophiles, but they make primary amines after reduction.